You ask the assistant a question and it answers in seconds. Full sentences, confident, like it read every manual you own. So here is the honest question. Does it know the answer, or is it doing something else? That something else explains everything the chatbot gets right and everything it gets wrong. Here is what is actually happening. A large language model was trained by reading a huge amount of text until it learned which words tend to follow which. That is it. So when you ask it something, and picture a plain model here, straight out of the box, not connected to any of your data or systems, it does not look up an answer. It builds one likely word at a time. Give it the start of a line, like the safety valve must be, and it reaches for the most likely next words. String enough of those together and you get a smooth, sensible answer. It is a prediction engine for language. That single trick is the whole machine, at least on its own. Later, we will see how to give it your real information to work from. This is the part that changes how you use it. It is not a database. A database stores your exact numbers and hands back the exact row you asked for. Every time, the same. The language model does not do that. It did not store your moisture spec to look up later. Instead, it learned the patterns of language and it reproduces them. That is exactly why it is so fluent and flexible. It can phrase almost anything. And it is the same reason it can hand you a confident answer that just sounds right. Hold the thought, we will come back to it. One more thing, and it matters on a busy floor. The model can only see a limited amount of text at once, its context window. Think of it as an attention span. Everything inside the window it can use. Anything that scrolls out, a number you gave it early in a long chat, or a whole conversation from last week, it simply does not see anymore, unless you hand it back. It is not being careless, it simply cannot look outside the window. So, the more you keep the right information in front of it, the better it works. So, the whole machine in two plain facts. 1. It predicts likely words. It does not store and fetch facts. 2. It sees only a limited window at a time. Nothing mysterious, and nothing that knows the way we do. But here is the good news. Once you know what it really is, you can say exactly what it is strong at and where it can go wrong. Let us start with the good part. What a language engine is genuinely great at. So, let us be fair to the machine. What would you actually hand it on Monday morning? Now, the deeper pattern behind everything it is good at, the real superpower, flexibility of shape, it is all language, yes, but the trick is it does not care what forms that language takes. Hand it a neat table or a messy paragraph, structured or not, and ask for either back. Messy notes in, a tidy summary out, a structured record in, a plain English explanation out. And its real standout is turning unstructured stuff, rough notes, logs, a long report, into something clean and structured, or the reverse. That is exactly where it beats narrow machine learning, which needs tidy, well-defined inputs and one fixed job. So the rule of thumb, if a job means wrestling with words or messy data in any shape, it is a strong fit, and hold on to one that might surprise you. Code is a language too. We will come back to that. You have already seen it draft the handover. Now, look at what kind of work that is. Scrappy notes in half sentences, numbers, a couple of complaints, and a clean structured summary out in seconds. What ran, what stopped, what to watch. The work that used to eat the back half of a shift. It is not working from memory here. It is reshaping what you gave it into something a person can actually read. Still worth a 30-second look before it goes out. We will see why. Two more that quietly matter on the floor. Explaining, you watched it do this with a procedure earlier, hand it a dense, jargon-heavy one, and it rewrites it in plain words a brand new operator can actually follow. same content, lower reading age, and translating that same explanation back out in a second language for a mixed crew in seconds. For a plant with new starters and more than one first language that is real, everyday value, the kind that adds up quietly across every shift. And here is the one that matters most in an engineering shop. It is genuinely good at code, not by magic. Remember, it predicts from what it was trained on, and these models were trained on an enormous amount of source code and technical writing. Code is just another language to it, so for your engineers, it is a real helper. It drafts queries and scripts, and it is a sounding board for talking through a changeover problem and brainstorming options to react to. Same rules as everything else, though. It drafts and engineer reviews and tests, and it never writes control logic that runs a line on its own. And this part matters. The engineer who owns the solution still owns the code and stays accountable for what goes live. So that is the honest good news. For language work, drafting, summarizing, explaining, translating, even writing code, it is genuinely excellent and it would earn its place on that alone. But notice the catch hiding in every example. It is only ever as good as what you give it, and it can hand you something that reads perfectly and is flat wrong. That is not a reason to avoid it, it is the reason to understand where it slips. Earlier, we watched the assistant hand over a spec with total confidence and be wrong. Now that you know how it actually works, we can answer the real question. Why does it do that? And where else will it slip? And here is the point of asking. Knowing exactly where it slips is what lets you trust it where it is strong. Slip 1, it can be confidently wrong. We call that a hallucination. And now the why is simple. Remember, it predicts the words most likely to come next. It does not look anything up. So ask it for the moisture limit and it produces a clean, confident 14%. When the real spec is 12, it reads perfectly. There is no doubt in its voice, no flag that it is guessing, because to the model, sounding right is the job. On well-known facts it was trained on, it is wrong only a few percent of the time. On open-ended answers, far more often. But your moisture spec was never in its training at all. There, it can only guess. And it will not warn you which one you're getting. Slip 2, and it is the one people miss. The model has no built-in sense of true versus false. It is not checking your answer against reality. It has no gauge for that. It only has one gauge. Does this read well? So it cannot reliably flag when it is unsure. It sounds just as fluent when it is right and when it is wrong. That is why you cannot just ask it, "Are you sure?" and trust the answer. The confidence is always there. The truth check has to come from you, or from the data you give it. Slip 3 we already set up earlier. It only sees a limited window. In a short exchange, fine. But in a long conversation or a new one tomorrow, a detail you gave it early can scroll right out of view. You told it the target was 12% an hour ago. That is now outside the window, so it quietly falls back to whatever is most likely and hands you 14 again. It is not being careless, it genuinely cannot see what dropped out. The longer the chat, the more you have to keep the important facts in front of it. So, 3 ways it slips. It can be confidently wrong, it has no sense of true versus false, and it forgets what falls outside its window. And notice, they are not 3 separate faults, they are one fact wearing 3 codes. It predicts likely words, it does not look up truth. But here is the part that matters. This is the plain model, on its own, with nothing built around it. It is not a dead end. Give it the right context, ground it in your real data, and keep a person in the loop. And both the accuracy and the memory get far better. Every one of these slips is predictable, and each one has a technique that tames it. So the real question is what you do about it. Anything predictable, you can design around. So 3 habits, simple ones, each aimed at a slip you just watched happen. Together, they cover every slip we saw. And the biggest question of all, safety. Get them right. And a tool that can be confidently wrong becomes one you can rely on. Habit 1. Give it the right context. Left to guess from memory, it hands you a confident 14%. But hand it the actual current SOP, the real document, the real number, and ask your question against that, and it answers 12, because now it is grounded in your data instead of whatever sounds likely. Same model, completely different reliability. This single habit answers 2 of the 3 slips at once, the confident wrongness and the forgetting. Give it the facts, do not make it recall them. Habit 2. Keep a person in the loop. Remember, it has no sense of true versus false, so someone who does has to check it before its answer is acted on. The model drafts and a person decides. That is not a lack of trust in the tool. It is using the tool for what it is good at, drafting, and keeping the judgment where judgment belongs. For anything that matters, a human reads it, approves it, and only then does it count. That one step catches the confident mistakes before they ever reach the floor. Habit 3, and it is the firm one. Keep it off the real-time control and safety loop entirely. Your bagging line runs on deterministic automation, sensors, a PLC, actuators, and that is exactly where it should stay. The assistant can sit beside the operator and advise, here is what the manual says, here is what I would check, but it never touches the equipment, at least for now, because near real-time control, a confident but wrong answer is not embarrassing. It is dangerous. The closer a task is to control and safety, the more the AI is strictly an advisor, and a person and the controller stay in charge. That boundary may shift as supervised action matures, but only ever under human control. Now, one honest reframe before we finish, because I do not want to leave you thinking this thing is weak. Everything we have said, the slips and the language-only strengths, describes the bare model on its own. Here is the everyday proof. Ask a plain chatbot what the weather is right now, and it cannot actually know. That was not in its training. Left to itself, it either tells you that, or it just guesses one from the text it was trained on. But you have all seen it, just go and check. It does not know the weather. It knows a service it can read the weather from. Connect the model to live data and real tools, and it stops guessing and starts grounding. Point that same ability at your current SOPs, your live plant data, your systems, and the bare tool becomes a genuinely powerful one. The precautions do not change. Right context, human in the loop of the control loop, but the ceiling goes way up. So that is how you use it well. In 3 habits, give it the right context, keep a person in the loop, and keep it off the control loop. We did not wish the slips away, we designed around everyone. And we saw the bigger prize, connected to your own data and tools, and the bare model becomes powerful. And next, all of that stops being good advice and becomes real techniques. Grounding it on your plant's own data, giving it safe access to tools, adding guardrails, and placing intelligence at the right level.